Okay, one more class of viruses that have RNA genomes, the double-stranded RNA viruses. Remember, these have to also bring in an enzyme because the plus part of the double-stranded RNA can't be accessed by ribosomes. So what these guys do, they bring in a polymerase. The polymerase makes mRNA from the double strands, which can be translated, and then eventually it will take some of those mRNAs and make them double-stranded to make new genome segments. And these mRNAs are capped. They do not have poly A. Not every reovirus has a poly A at the 3' end. Some of them do. And these this is a very simple copying. The mRNAs are full-length copies of the negative strand, so you have no issues with making up the sequence. These are what these viruses look like. Remember, they're spherical and they have two shells. They have two concentric icosahedral shells. And here's the intact virion. And we talked last time about it. As these viruses move through the endocytic pathway, the outer shell gets digested away. So you're left with a core. And it's within this core that the mRNA synthesis actually occurs. So here you can see the double-stranded mRNAs, the double-stranded genome RNAs of these viruses. They're all packed into this core. And each segment makes a single mRNA that makes a protein. You can see there are a lot of them here. And again, all this happens in the particle. The RNAs never come out. So let's see how that happens. Here is an infecting reovirus. It gets taken into the cell by endocytosis. As the endosome fuses with lysosomes, the outer shell is digested away, and eventually that hydrophobic particle gets out of the endosome into the cytoplasm, and then it still has its double-stranded RNAs in it. You can see the green segments here. And the mRNA synthesis begins. It's got the enzyme in the particle. And the RNAs come out of the five-fold axes of symmetry. You can see them coming out here. They're capped mRNAs. So the enzyme stays in the particle with the genome, and the mRNAs extrude from the particle. And eventually those mRNAs get translated. They form new particles with a single mRNA in each one. And then those mRNAs get made double-stranded inside the particle by the viral polymerase. And then it leaves the cell. So the point here is that the virus particle not only brings the enzyme in with each of these segments, but does all the synthesis within the particle. So this is really a virus that never uncoats. It never liberates its genome. Right? This is just a interesting cryo-EM structure of rotavirus particles in the act of making mRNA. And you can see here on the bottom, this is one five-fold axis of symmetry. And you can see an mRNA coming out of the particle. Now the idea here is that below each five-fold axis of symmetry, there's one segment and one enzyme. So each segment is located right below the five-fold axis, and after it gets out of the endosome, that enzyme produces mRNA that's extruded from the particle. It's really a neat method of doing this. Now because this is double-stranded, you may ask, is this conservative or semi-conservative? You know, when you replicate DNA, when we replicate our DNA genomes, we do it in a semi-conservative fashion. That is, the two strands separate and then each one is duplicated. And so some of the double-stranded RNA viruses do this. But reoviruses, the ones we've just been talking about, actually do conservative replication. They take the genome, they make an mRNA from one strand and then make that double-stranded. So actually only one strand is being copied. That's why it's called conservative replication.